this is an educational session, so I'll try to provide some details on how usually academic publishing works and what are the issues today to get the academic publications fully accessible to both students and researchers who might need this. So I'm starting with a somewhat personal part of the story, and this is a student's part and what they really need out of this topic. So this is a real person, and he's residing next to us here in Minsk, Belarus. He is a Bachelor of Science, he is fully blind, and he wanted, so that's the citation from him, that I was willing to continue with master in mathematics or computer science, but unfortunately all advanced books were not accessible to me. So he was able to survive on the level of bachelor with, well, specially crafted books, and, well, school books at school, and then further on bachelor level textbooks. But unfortunately, the way further to science, to scientific research is close to him. Well, simply there is no information accessible to him at that level. So we are working together with him on the development of a new LaTeX package for accessibility, and I'll be speaking a little bit at the end of the talk where we are now, but the main message of the talk is where the problems actually are now. So the next part of the story is scientists, those who really generate the academic content. So what's going on here? Well, I took as an example one of the online archives, which is used today, I guess, across multiple fields, well, physics, mathematics, computer science, and, well, a bit less, but still in biology, finance, statistics, engineering. So arXiv.org, well, spelled in this a bit strange way, is an electronic preprints or e-prints archive today, where essentially every scientist can upload their results or articles. There is a little bit of moderation, but that's not a real scientific journal. Yet it's a very good vision of what's going on there. So it's, well, close to 1.5 million of articles already, and I'll provide the statistics soon. So how it works? The format of these e-prints is always PDF. So whoever wants to go there, check, he would be able to find tons of PDF documents of scientific publishing. So it's huge test set for those who want to see how this really works. However, when it comes to the submission format, that's by, I think, 90% or even 95% of all texts submitted to the service are prepared via LaTeX system. Well, it does accept occasionally PDF documents generated from some other sources for HTML, but the strong preference is towards LaTeX. And the service itself, it is maintained by Cornell University, generates PDFs on the fly out of their archive. Well, this is a little bit of statistics here. So we see the, well, something in between linear and exponential growth, but that's, well, at the moment, about 12,000 articles uploaded monthly to the service, and the number is growing. Interestingly, they really trace everything since August 1991, so it's close to 30 years of scientific publications now. And this is the download rate that they have today. And that's, to me, that's absolutely amazing, with close to 30 million downloads each month. So this means that people do read academic publications, they do need to access them, and I don't have, of course, exact figures, but I believe quite some number of these people require accessible formats. Now I'm taking just a random publication, one of the latest ones taken randomly out of this arXiv. And on the left, you see the PDF file generated from the source LaTeX document. So you see on the left side, it's been generated on 7th of June, so it's a very recent publication. And I run it through, well, the standard PAX3 accessibility test to see what's going on here. And, well, not surprisingly, we see pretty bad results. So apart from the pure PDF syntax, all other tests fail. So we don't even speak about structured, well, tagged PDF or natural language authentication. Even not all fonts are embedded. And, well, metadata is not present, etc. So from the accessibility point of view, that's a very poor result. And that's not because I've taken the wrong publication. I could have taken many of those. I'll explain very soon that the tools that are available at this website, arXiv.org, would not generate any document which is close to be accessible. That's all free arXiv. So what happens in the commercial world? We have a big industry of academic publishers here, and certainly they do care on well, that their publications are accessible or not, and they, in many cases, they're required to care by the legislations. So this world is, there are several big players. And the reports, the latest reports I was able to find by about 4 years ago. So the total industry combined is around 60 billion euro, which is now like 70 billion US dollars. And the biggest players, like half of this domain is divided between 5 big players, and Elsewhere and Springer are probably the most well-known. And well, just as an example, Springer has in its collection, well, almost 3,000 scientific journals and about 300,000 electronic books, while Elsewhere is concentrated around scientific journals and actually other data, academic data publishing, not just publications like paper publications. So let's look at what's going on there. I'm taking a random electronic book. Well, that one is a bit classical, and I do the same. I run through the accessibility test check, and now this seems to be a bit better. So we see a lot of green checks now, and like fonts embedded, role mapping is here, the document is tagged. So, well, this, well, apart from metadata and natural language, this seems to be almost okay. And then the next thing, of course, is to check what does this really mean. So if you go inside and inspect what's inside this tagging, we see, well, not surprisingly, a very standard trick. So this is just an image, and this is tagged as an image, and this is a complete page content. So it's essentially all book is is a collection of images scanned and OCR'd. So the text is selectable, it's present as a textual content or alternate content of an image, but of course, there is nothing like this very neat structure elements we like to discuss, like table of content and other kind of very important structure elements. So it's just plain images. And again, I wouldn't blame too much the publishers, because again, there are simply no good tools to make this scientific publication look nice. When you have a book of about 1,000 pages and you have, well, 300,000 such books. What about maybe that was an old scanned book, but let's look at the modern journals, so this time taken from elsewhere, theoretical computer science, and well, again, running through the same accessibility test, we see absolutely the same results as what we had for the free articles on arXiv.org collection. Again, nothing like structural elements present, no metadata, no natural language identification. So essentially, and actually the layout is not that simple to automatically guess the reading order. So I would assume that, well, even with all the smart heuristics, it would be very difficult for a blind person to understand what the screen reader provides to this person. So, well, now we see what the problem is. So who to blame? Well, let's look at the standards point of view. This is what PDF Association is actively develops. Well, actually, ISO actively develops, and PDF Association provides technical expertise. And on the ISO standards, it all looks almost perfect. We have the notion of a tagged PDF back to PDF 1.7 and even earlier, but it's refined in PDF 2.0. So accessibility in PDF is well defined by yet another ISO standard, PDF UE1, and we have PDF UE2 based on PDF 2.0 under development right now. So MassML is a syntax to present mathematics, well, to store or to exchange mathematics. So it's a format to exchange mathematical data for mathematical formulae. So it's specially cited as a very exceptional namespace in PDF 2.0 standard. So it has a very special role there. The standard gives pretty clear instructions how the formulae could be made accessible by means of either MathML namespace or by attaching MathML or LaTeX representation of a formula via so-called associated files. This is a notion that was introduced in 2.0. So it looks like we are all set. But unfortunately, as of today, there are no authoring tools that can generate fully accessible scientific publications, either PDF 1.7 or PDF 2.0. So the only accessible PDF files with formulae I've seen so far were very carefully crafted by either individual scientists or some software engineers, but they were always like a work of several days or even months for a single very carefully designed document. So it's certainly a very interesting initiative, but nothing close to the production of millions of academic publications we have today in this world. So what about the tools? Maybe this is something where the tools can pick up. So this is a very general picture of how I see this today. So we have three different communities, in fact. So one of them is an authoring software. So companies and sometimes communities, like in case of LaTeX, that maintain or develop authoring software. And just to be clear here, when we speak about scientific publications, there is a term called precise publishing. So we care about every point or even smaller dimensions when it comes to shifts of a glyph or a sign or a point or a space. Well, not many tools actually do perfect work in this domain, but there are certainly some. On the other side of the picture, we have consumers, and by consumers I mean screen readers and accessibility APIs, which are aimed to convert electronic documents into something accessible by disabled people. So, for example, while screen readers turn the publications, turn electronic documents into voice, there are technologies that would use braille display, etc., but still they need to understand what's inside the documents and then turn this into something understandable to a visually disparate person. And on top of this is a very important cloud, which is called ISO standard, that says how this can be, how the information can change. And I outlined before that from the standards point of view, things seem to be fine. So where is the problem is then? Now let's look at the right-hand side of the picture. This is where we have screen readers and platform APIs. So just to list a few main screen readers and players in the domain of accessible mass. I selected two most popular screen readers today, which would be NVDA on open source software and the JAWS from Freedom Scientific, which is a commercial software. And they all use two different technologies to my knowledge. One of them is Mass Player, developed by Design Science, which provides universal MassML support. But there is also an open source initiative called MassJogs, supported by American Mathematical Society and SIAM, that the aim was to turn math accessible on web. So, for example, if you go to any Wikipedia pages which contain formulae, most likely they are rendered directly from LaTeX or sometimes from MassML using MassJogs technology. So it's more complicated than that, so they optimize it heavily to make sure that it goes pretty smooth and fast, but still, there are not many technologies in this world that would understand the mathematical formulae and would make them accessible, would understand the semantics or presentational aspects of the formulae, and would correctly turn them into voice, for example. And of course, there is an excessive set of platform APIs, and here they're not aimed for mathematics. They're certainly aimed for more general documents, but there are many of them. So it's Microsoft, macOS, and Unix have different standards, and Microsoft has two actually, plus mobile platforms come into the game, and they all come with their own technologies for accessibility. So it's really quite complicated thing for screen readers to turn any electronic document into voice, not saying about mathematics. So that's quite complex and delicate development. But I believe this is not where the problem really lies, because both NVDA and JAWS try really very hard to make math accessible, but they're simply not able to, because they claim they do not get the required information from PDF files in particular. So there is simply no information to process for them when it comes to formulae. So what about the authoring software? And I have here two examples of authoring software. The one is, of course, InDesign, and it's used very heavily in textbooks production. So when it comes to high school textbooks, InDesign is one of the most popular tools here. And however, there are no built-in tools to associate MathML to formulae. This is partially resolved by third-party add-ons to InDesign, and looking at the agenda of the conference, I know there was supposed to be a talk about one of such tools. However, when we speak about massive production of electronic documents, and especially in the high level, that's always it always boils down to LaTeX or TeX technology. Just to give you a very brief overview for those who haven't heard about this or just didn't know the details. So actually, I would consider TeX system as something like a prehistoric part of electronic publications, and it preceded a little bit PostScript and PDF. So the system itself dates back to 1978, and surprisingly, even at that time, it contained a lot of things we enjoy today in PDF, like device-independent format as a result of the work of the authoring software, output format, which is device-independent, vector fonts, paged output. So unlike PDF, unlike PostScript, the GNU's publishing system was always paged from the beginning. However, only in 2000, the community of LaTeX or TeX users realized that PDF output is very much more convenient than the original GNU DVI format. So today, for example, all the LaTeX tools generate PDF as an output. So PDF already plays a huge, significant role in the LaTeX community. Again, surprisingly, this move to PDF output was added by a single person, a Vietnamese origin who did this as his PhD thesis back to 2000. And already at that time, PDF output supports many PDF-specific features like hyperlinks, bookmarks, etc. When we see what's going on now, so the PDF, LaTeX has a huge community, LaTeX users or TeX users has a huge community. They were able to add the support for PDFX and PDFA, unfortunately only levels B and U. So you see that level A is not available and PDFUA is not available exactly for the reason that LaTeX is not able to generate tagged PDF documents today. Just a very, very brief sketch of how it looks like. So this is a very simple LaTeX document. I'm not going to dwell into the details. So it's a very special format. To those who have seen this, that's very familiar. To those who hasn't, well, I'm not going to explain what it is. But this is what every scientist does or types when he or she wants to publish an article. And there is a so-called compilation process that turns this fluid text document into something that looks like a normal PDF document, already including bookmarks, hyperlinks, and, something that looks like a nice structure, but there is no structure here. So, the community, LaTeX community, is very fragmented, and they try to modernize LaTeX a little bit. And just to explain, GNU used his own programming language to develop TeX publishing system called WebSphere, from where the source code could be turned into C, C++, and then compiled into native binaries. So this thing so today people are not able to support this anymore. Luckily, there is a so-called LaTeX community that converted all the source code base into C++. So LaTeX is fully open source, all source code available, all formatting rules, etc. All internal structures are well documented. On top of this, LaTeX had so-called scripting and callbacks for all steps of formatting. So to those who want to implement their own line breaking algorithm, they have all the callbacks and they could go and implement their own, for example, InDesign like line breaking, or however, well, I think there are several. There is a full Unicode support, finally, all full modern font support, including OpenType support with all the modern scripts. So from this point of view, LaTeX seems to be quite modern. Moreover, there was an attempt to come up with a new markup which is different from LaTeX and which would be more adjusted to tagged PDF needs, and that's called context. It's more like XML syntax, and it works pretty good. However, it's not compatible with LaTeX. So this is a big problem. So when you have 1.5 million of documents sitting on your back, plus like 12,000 generated monthly, and they all are in a different syntax, it's not easy to train people to use a different syntax. So how it all works today? There is a very, very limited set of tools available for accessibility purposes. Well, they are called packages in LaTeX, and I put here three. Well, these are actually the only three that come up when you do search for LaTeX accessibility. Not many, so there are about several thousands of various LaTeX packages that allow you doing very special things with LaTeX, including like chess, party notation, or chemistry, or very smart diagrams, etc. But when it comes to accessibility, there are just three packages. And one of them is tag PDF is probably most interesting from the tagging point of view. So it's an experimental tool with tagging and accessibility, but it just adds low-level comments to add structure elements and marked content sequences. So if somebody wants to turn a LaTeX document into a proper tagged PDF using this package, he or she would need to go through all the document and manually mark all the structure elements. There are a few other tools that add the support for alternative text for images and actually any span marked content sequences, language identification. There is a very interesting initiative from the University of Turin that would do automatic conversion of LaTeX formulae into span elements, and the original LaTeX would be put as replacement text. They believe that, at least the real-world tests show that this way the replacement text, which is the original LaTeX formula, reaches the screen readers, and the screen readers voice it over. So to those who understand what it reads would understand a little bit what the formulae are. But that's definitely not how the standards. So the standards would not approve that.
You have 2 minutes.
Yes. Actually, I'm coming exactly to the summary. To describe standardization.
Thank you, read my mind.
Yeah, so I have exactly 2 slides. So the summary is, despite all standardization efforts, there is, first of all, no clear guidance on how mathematics should be placed inside PDF, which is accepted by both tech and screen reader communities. They tend to argue that what standards prescribe is not what they want. So as a result, there are no working implementations of the authoring software, no tools for individual scientists and academic publishers to generate accessible scientific content in PDF. Plus, in addition, we have a community challenge. These are 3 different communities, so tag, PDF, and accessibility, that have very little context. This is improving also thanks to the activity of PDF Association, but there is still not much intersection, for example, between tag and PDF communities. And of course, there are usually, as usual, there are finding challenges for open source development, which is all LaTeX essentially. So way forward, and this is what we think as the way to proceed. So we collaborate now with the University of Turin, Italy, on the package of accessibility that would work as a prototype for fully automatic PDF tagging based on LaTeX semantics. So there is a lot of LaTeX semantics, and just the challenge is to bring the semantics to PDF. In particular, like adding MassML LaTeX syntax for formulas as associated files in PDF 2.0 way, and making sure that we are fully compatible, for example, with a derivation algorithm that would work as a test. And it would convert a formula to something where mouse jogs can help to generate the voice representation. And there are no illusions here. This would be only a starting point for tests and discussion between different communities. But I believe this is really the main challenge, how to make sure these communities start to speak to each other. So I'm all done and would be happy to answer any questions.
I have a question.
Yes.
Hear me? Your emphasis is on basically accessibility. But what about the situation where one wants to put a formula into a scientific paper such that one can extract that formula and use it for subsequent experimentation? For example, to take that formula out and then use it in a spreadsheet or test against data that was otherwise used to come to conclusions of that paper.
Yes, I understand the question.
Yeah.
I don't, first of all, that's a very good question that I don't have an immediate answer. I'm not sure that MassML is fully adequate to work as a data interchange between the scientific publications and the, computational software systems. And, LaTeX here is even worse because it's not an ISO standard or not a standard in any, normal terms. I would assume that, again, we can think about associating some special formats with formula, and these formats should be good enough as an input for the computer algebra systems, for example, like MATLAB. And that is the way to go. So PDF 2.0 does provide the mechanism to associate any supplementary data to formulae, and this data does not need to be a source input or source data, but it can be data that could be then further extracted and interpreted by the computer algebra systems.
I think we have to end now because we've got to switch over to the next speaker.
Okay.